Okay, hi everybody. I think this is going to be a fairly short one. What I want to show you in this video is just how to use a package called matplotlib, all one word, to create scatter plots. We're going to use matplotlib quite a bit. You've already seen its results when I created those banknotes graphs in the supervised classification activities. I used matplotlib for that. And we're going to be using it to create scatter plots of our data and occasionally bar graphs. I'm going to show you how to use scatter plots. That's all you really need to get you going. And then I'm going to point you to a reading for how to do bar graphs and other stuff when we need to do that. The code I'm going to show you is in the example code for week 3. Under resources here, you will find selections from Data Science from Scratch, which is this book here, and you have to scroll down to chapter 3 on visualizing data, and it shows you how to use matplotlib, which is what we're using today. It starts off with line graphs, which we probably won't use at all, bar charts, which you'll use a little bit, and then does a lot about bar charts, how to make them look nice. Line charts now. And then finally scatter plots, and that's what we're going to look at today. So I'm going to walk you through some scatter plots code. Okay, so this is the code that I want you to take a look at, but I'm just going to work over here. We'll run the code eventually, but I'm going to work over here in this window to show you how it all works. So the first thing you have to do is import matplotlib. And we're actually only using part of it. So from matplotlib, we are importing pyplot as PLT. So that just gives us pyplot, but with the name PLT, which is a little bit shorter to type. And we're going to need numpy as NP as well. Okay, so we need those two modules. You'll see them being imported up here. And we want to create, let's start by creating some data. So I'm just going to copy this over here. Okay, so we have data. I'm using np.array to create a two-dimensional array of data. So this is the idea here, is that these are points to be plotted on a scatter plot. These are x and y locations to be plotted. If I want to create a scatter plot of that, first thing I have to do is create a figure. And you can put a number here if you want. So I can say this is number 1. It does work to put text here as well if you want. So I could put something like simple scatter, and that would appear as the title of the graph, but I'm just going to put 1 here. So that creates a new figure. And then I'm just going to skip right ahead to plt.scatter. Now the thing is, we have to put, if you notice what pops up here, whoops, try that again. The first two parameters are called x and y. The rest are named parameters with their keyword parameters with default values. So all we really have to provide here is an array or list of x values, an array or list of y values. But usually our data doesn't come to us that way. Usually our data comes in columns like this. So you have to be able to pull out a particular column. And you do that using slices. So if you remember, 1, 2, 1, 1, will get me row 1, column 1 when it's an NP array. If I go like this, what that's telling me is it's telling me all rows, but only column 0. So I can pull out column 0 that way, which is the x's, and column 1 that way, which is the y's. So 5, 2, 9, 3, that's column 1, column 2. So what I want to do is plt.scatter data, comma 0 like that, comma data, comma 1 like that, boom. So that creates a scatter on the figure that I created earlier. So there were two commands. Figure created the figure. Scatter puts the points down as a scatter plot. The only thing left to do is show it. plt.show. And it usually pops up behind the window, which is annoying, but there it is. Okay, so it chooses, based on the values, it chooses an appropriate x and y scale, and then it plots them using default color and default marker. And we can change all of that stuff. So let's do this a second time. But this time, so I'm going to create a new figure, figure 2, and I'm going to scatter. No, actually, first thing I'm going to do is I'm going to go plt.xlim. So these are the x limit, and the help for this is not very helpful. It just says args and quargs. So you just kind of have to know, and I'll show you where to look this stuff up. So say we want to do an x min of 0 and an x max of 10. So what this does is x lim is going to set the boundaries of the x-axis. So this, by default, it went from 2 to 9 on the x-axis and from 4 to 9 on the y-axis. We're going to try and regularize those. So we're going to go from 0 to 10 on the x-axis. And we're going to do the same thing. Y lim, y min equals 0, y max equals 10, like that. Then we're going to do the scatter, which I'm going to just get back over here. So all this stuff is now applying to figure 2, the one that I've just created. And if I go plt.show again, we should get a second figure here. Same points, but now the axes are going from 0 to 10. Okay. You can also change, let's do figure 3. I'll just skip right ahead to the scatter. You can change the color. C equals red. There's a bunch of stuff you can do with color, and I'll show you how to get the full reference. But basically, it accepts most CSS color names. And you've got marker, which can be a bunch of things. I'm going to use capital H, which I think means hexagon. So it's a one-character code, and I'll show you where to get them. That changes the way the marker looks. So by default, we had blue circles. When I show this one, we should, if I got it right, have red tiny little hexagons. I don't know how well you can see that. Okay. So that's the basic idea. That's really all you need. You need to be able to pull columns out of your data, which you do like this. If you had multi-column data, you might pull out column 2 versus column 7 to graph those on the x and y axis. But other than that, it's going to be the same. You need to be able to set the color of the point and the style of the marker, which we're doing here. There's some other examples here. You can set a title for your plot and an X label and a Y label. So I'm going to run this code with Control-Shift-E. That's the second graph. This is the first graph. So I set color to black and marker to X. And here's my X label and X-axis and Y-axis label and my title here. That was set using plt.title, X label, and Y label. I put a URL here. If I go over here, I can show it to you. This is the matplotlib API. It's big, and there's tons of stuff you can do with it. But if you go over into scatter, which is the function that we were using, go over there, it explains the parameters to you. So see, we use the C parameter for color. You can also create sequences of colors so that it cycles through a sequence, but we're never really going to want to do that, I don't think. And then marker here is the other one that we used. As you can see, there's a bunch of other parameters. Feel free to use them. But what I wanted to show you is if you click here, matplotlib markers, these are all your markers, and these are the codes to get them. So for example, here's this weird triangle up one. If I put marker 2 there, so if I change this to the marker 2, I will get weird little triangles. That's my markers. Okay, so that's where you get that. You can look up all the other commands here as well. If you go back, xlim and ylim should be here. Yeah, there's xlim and ylim. We use title, which should be up here. So I'll let you guys explore this as much as you want, but we really only want to do some basic things with it. The other thing here is this one here. So here I'm creating this plot here. Let me run this again, the second plot. So it creates this one here. It's a random scatter with 2 types of data. And a couple things I want to point out is, first of all, I create the 2 plots. Whenever you call the figure method, you create a new figure, and then you can configure it. I only call show one time at the end. That kind of is a little bit more efficient, I guess. So create all the figures you want to create, and then go show, and they'll all pop up each in their own window, on top of each other usually. What I've done here is I've just used np.random.randint and rand to create some random points. And I have used, when I did xlim, notice I pull out all of the x values, and I set the minimum and the maximum plus 1, minimum minus 1 and maximum plus 1. If I didn't do that, what it would look like is it just gets a little bit closer to the edge, I guess, than I wanted it. But I wanted to show you that you could compute from the data what your minimum and maximum should be. Oh yeah, no, it gets a little too far from the edge. I wanted to maximize, use the most values that I could here. Without this, it set the margins a little bit too wide on the data. So you can set them based on your data using the min and the max functions here, min and max. If you take a look at the data, this is what it looks like. If I go data.shape, it's 100 rows, 100 points, 100 two-dimensional points. And what I wanted to show you here is that when I scatter them, I call scatter twice. The first one is for the first 50 points. So data, that means from 0 up to but not including row 50, so that'll be the first 50 rows, and then column 0, that gets me them. And then if I want the rest of them, it's 50 colon to split it up so that I get the second set of x values, and that gets me the second set of x values. And I use a different marker and a different color here to scatter them. So you can scatter numerous times on the same graph. And that's how banknotes was made. So banknotes is a bit more complicated. This is another example, piece of example code that's there. There are 4 CSV values, 4 CSV files, sorry, that I read from to create that picture that you saw in the handout for the classification activities. Okay, that's it. And there is an exercise or two that I would like you to try. Just to get your feet wet, just do this. Generate 1,000 random integers from 0 to 100 and use pyplot to plot them. Try to make it look exactly like this. So get your x and y axes looking like this. Get your marker and your color as shown. And then this one here is slightly more challenging just because if you haven't done this before, what you want to do is generate random values and multiply them together like this to create kind of a blob with a center. It's sort of a normally distributed, or not normally distributed, but it creates a slightly more interesting distribution. This is just a flat distribution with random numbers from 0 to 100 in both directions. This one's a bit more interesting. It looks like a blob that has a center and then has some outlying points. And you do that by multiplying things together. So give that a try. We might just try this one. If you can do this one, you're fine. This one's just kind of interesting. Maybe we'll do this one in class when we get there. Okay, so that's it. Next video is going to be about the assignment 1B. So I'll see you there.